Hey, hi friends, good evening everybody, and welcome to the session on GeoSpatial analytics. We will today try and understand the data mining concepts further. In the last session, that is yesterday, we were discussing about some of the concepts with respect to how the analytics is basically run and all that. So we'll try and do something right further on understanding on how the data mining concepts are generally used in various areas. I will also today talk about the Python program. Probably we will try and see a small use case, one or two use cases we will see, and post that we will also probably tomorrow we'll look into a few more examples. So that would be today's agenda. Now, yeah, let's start. To begin with, let us try and understand the concept that we discussed yesterday with respect to crisp MLQ methodology. So the standard process with respect to implementing the data science or analytics is with respect to using the process methodology called crisp MLQ. Right, this is the methodology, and it's called as cross-industrial standard process for machine learning implementations with quality assurance. That's the definition, and this is the global standard, and it is used for any projects which basically involve data in them. Right, data-related projects, especially with respect to analytics or machine learning. It is a standard product development lifecycle process, but specifically designed to deal with the projects on machine learning front. So as part of a machine learning, there are certain things that we will have to understand, and specific to them, we have these standard 6 steps. Right? So it contains 6 phases. And we'll look at some some of the concepts yesterday. We will continue that. So 6 phases. The first phase would be business understanding, and of course data understanding. When we talk about business understanding, we're trying to understand the requirements, right? I was giving a couple of examples yesterday on the example that we were discussing about yesterday was the pandemic scenario. So primary objective is to try and identify the cause of the outbreak, right? Cholera outbreak, so that we are minimizing the deaths, which basically are causing due to that problem. Right, so that is the primary objective. The constraints will also be there. Constraints are the challenges. The availability of appropriate data would be the first challenge. And there is no proper technique or method which can allow us to detect those the pandemic outbreaks. So these are all kind of challenges. Now, along with these, right, we also have to look at the data understanding part. When we talk about data understanding, we're basically looking at what format of data, right? What size of data, where is it getting stored, how the data is getting stored, right? How we can access those, how we can process this. In order to process that, what kind of tool should we use? So basically, we are planning with respect to processing of the data, right? And in order to do that, in order to plan, we need to understand the characteristics of the data in the first place, right? So that is these are some of the important things that we'd have to look at. Then, if I have to put this in a very simple standard format, then we are looking at The points like whether the data is very big. If it is, then we need to have a solution which can allow us to deal with that large amount of data. Your computer probably may not be sufficient. Then format of the data. If it is a standard format, then from analytic perspective, you have different techniques to deal with that. But what if your format of the data is something really different? So it is different than what would you do? For example, when we talk about data, right? Yesterday we were looking at different forms of different file formats, right? Of course, these data points that we are using are broadly classified into vector data and raster data. Raster is nothing but image data, in short, you can say, right? But the formats of the data are going to change, isn't it? That there are different formats. So we need to look at all these different file formats. For example, geotag the photos, GeoXML, GeoPandas, shapefiles. So yesterday we were looking into these some examples, right? If it is a standard spreadsheets or comma separated files which are in tabular format, then it is easy to deal with that. Right? So we need to also understand the format of the data, and that would basically give us a hint on how we can process it. Okay. Then once we basically have identified the requirements, understood the formats of the data, right, understood characteristics of the data, then we need to look at how we start processing it, right? Data cleansing. So we need to ensure that we prepare the data, we need to clean that particular data so that it is ready for us to handle or process it. This is where analytics actually start. Right? When we talk about data science or analytics, then we will want to generate some reports on your historical data. So as part of your data cleaning or pre-processing, we will do some preliminary calculations, preliminary analysis, and those preliminary analysis will tell us a lot about the data that we are holding. Okay, then after we do all this cleaning, transformations, right, managing the data in from one form to another form, we call it as transformations. We fill in the details by doing imputations if there is some data missing, right? All these things are done. Assume. After this, we will start implementing the data mining techniques. Now, for geospatial data, the analytics strategies that we are using will be a little different, but in general, the concepts would be same. It's just the application will vary because the data formats and all that are varying here. So data mining, broadly, they are classified into two formats. One is called as unsupervised learning. The other one is called as supervised learning. The unsupervised learning basically talks about trying to extract some kind of information from our data. Historical data, right? We're trying to identify some hidden patterns in that. Then we also have supervised learning. The supervised learning is where we actually do some kind of predictions. And if our data is time bound, right, then it is called as time series. For example, temperature variations we want to check, or rainfall we want to check. So the details are captured on the same location, right? Location wise, it doesn't change, but the readings will happen at different time steps. And the granularity is something that we'll have to define. The granularity could be every 1 hour, every day could be every 1 hour, or every minute as well. But ultimately, we are taking the data from the same location at different timestamps. So only time varies, hence it's also called as time series. Now, under the unsupervised learning technique, there are many strategies that come into picture, or many things that are available. So if you look at the unsupervised learning technique, here we speak about concepts like segmentation. Then we might want to do dimension reduction. Then you want to define some associations between the entities in the data. Or then you might want to talk about the recommendation systems for your data. Right? So on and so forth. There might be different things that come into picture. Then we also use network analytics. Network analytics is a study of networks which are represented generally in a graphical manner. Right? Interconnections, basically, we're talking about between entities. Right? And then we also have a special case called text data mining. The data itself is textual data. Right? In vectors, basically, in vector form of data, we generally have text data. Even in raster forms, right, we basically have text data. It's not just image data that we will look at. Then, if I talk about supervised learning, then here under prediction, we will have classification models. These classification models basically speak about different techniques which will allow us to group the data into certain labels. And in order to implement shallow methods, we basically use techniques like this. Bayesian classifier, which uses probability concept. Then we have something called as KNN, nearest neighbor. This concept uses distance measure. Distance between the data points, right? If they are less, then that means the characteristics would be similar. Say, for example, if we talk about the characteristics of data points or location, for example, South India, the characteristics would be similar for all the locations in South India compared to the characteristics of locations in North India. Or, for example, geographically, if you talk about different planets. I mean, I'm just talking about the distances, right? So conditions will vary. So that is the logic which is used in KNN. Then we have the tree-based algorithms, and these are very, very popular, in fact, you can say, in the modern day analytics study. Tree-based algorithms are becoming very, very popular. Right? So you might want to look into these options as well. All right, next. We basically talk about the ensemble techniques as well. Ensemble techniques are those techniques which are generally developed using multiple techniques. We don't use just one technique. We will use multiple techniques. Okay, so that's about the ensemble methods, and we have variations. Ensemble methods are very, very interesting because it's basically speaking about the case where if one solution is not reliable, if one model is not reliable, then we go for second models, verification as well. This is going to allow the model to get better results when more reliability will be there. Okay, so that's about the ensemble techniques. And when we talk about ensemble, it's just like your doctor and patient case. If we have some discomfort, we go to a doctor. And whatever the doctor is prescribing or are investigating and identifying, right? From the diagnosis, doctor is saying that you have XYZ issue. We generally don't want to believe that if it is, right, not something that is expected. So we don't want to trust. So what we do? We go for second doctor. Second opinion. This is to improve the chance of the outcome being correct. The idea is the doctor who's initially doing the diagnosis may be wrong, isn't it? So the initial doctor, whoever is working, probably is wrong. After all, doctors are also humans, right? So they tend to make mistakes. So this could be a scenario. So we might want to go for second doctor's opinion. And if both the doctors give the same result, then you can just say that, yeah, maybe this is true. This is because both the doctors going wrong in the same way for the same patient is highly unlikely. One doctor may go wrong, but both the doctors, same mistake, maybe not, right? So it's not something that we should see regularly. So the reliability or the confidence improves when you are getting the results from multiple right doctors. The same logic is applied in your ensemble techniques. Ensemble techniques. Basically, it is nothing but combination of multiple models and their results. Right? So that's about your right ensemble techniques concepts. Now, irrespective of what we are basically dealing with, right? Ensemble techniques and all that. Every technique will have right, something called as parameters. Those parameters can be fine-tuned in order to get better results. Okay. This is called as tuning of the model. And after tuning, we go for evaluation of the model to understand whether this is a good model or not. All right. All right. Next, we will try and now try and understand a little bit of Python programming because that is required. Okay, without Python programming, we will not be able to deal with or generate any of the solutions here. All right. So what is Python programming? The assumption is that the basics of Python programming are something that you are familiar with. That's the assumption. And like yesterday, we have seen different types of data. Similarly, we are going to look at different types of packages. Now, but what is a package? What is a package and in Python? Python programming is basically Python programming basically is running on various capabilities. I mean, the software is having the capability of various things, right? And one of the capabilities that we are going to use is called as functional oriented programming, right? It's called as functional oriented programming. Functional oriented, right? This is very important. This basically means functions are written and your entire execution or your development is revolving around the functions. These functions are nothing but instructions, right? Instructions are nothing but lines of code. And Python programming is a communication medium. It's a language. So you will be communicating the details with respect to your computer, saying that, hey, you have to do this, do this, do this. Right? Instructions, lines of code. Now, the beauty of Python programming is that it has this capability, right? Function-oriented capability. So that means the codes or the functions which have been written by somebody else, you will be able to reuse them, right? You can absolutely get those codes and reuse them, right? So that is your package. Now, there are certain mandatory packages that you will be requiring to understand, right? And I'll talk about those package names here, and I'll try to explain certain basics, but post that we will have to look at specific libraries which are designed and used for geospatial data. Now, package has to be seen as a folder. Okay, package is nothing but a folder. Imagine these packages all are placed in a centralized location, which is called as pypi.org. Okay, this is the centralized repository, pypi.org. So you have a package here, and you're trying to use that. Now, what we do is we try to get this package into the computer, into your CPU, and then try to reuse that particular content. Okay, so that's something that you need to work out. Now, how to download and all that is again technique. There are tools which basically allow us to bring these libraries or packages into your local system. The tools that we have is something called as pip install. Right. We also have something called as Conda install. Right. Or we can directly download it from the Git location if you have something called as Git location. We also have something called as ec_install. This is also another very simple function that you can use. This function is specifically used for Windows systems. Right? So these are some of the tools that we use with respect to trying to download the software, that is the program or the folder, into your local machine. So the syntax is basically package name here. Okay, this is package name. Here also we have we basically use Conda install. This is the keyword that we use, and then package name. Same thing with respect to pip also, we will say pip install package name. That's the syntax that we have with respect to the Python software installations. Next. Whenever you want to deal with the data, right? As I said, there are certain packages that you will have to by heart and speak about. So let us try and talk about those things. One of the important package is Pandas. The Pandas library basically speaks about Python data structures. So whenever you have a tabular format data, then you might want to read the data into the system using standard library, which will allow you to automatically read the data types. So dynamic programming capability, right? So that is another thing that you need to do. So that is basically done using Pandas library. Then we have NumPy. This is also called as NumPy Python. This is used for arithmetic operations. Then for some of the visualizations, basic visualizations, we use Matplotlib library. This is nothing but MATLAB plotting library is used for visualizations. Then for machine learning perspective, we have something called as sklearn. Under sklearn, you have right, standard libraries, machine learning libraries that we will in general use. Okay. Next, if I have to talk about certain libraries which are specific to your geospatial analysis, then we'll have to deep dive onto these. Now, I will be also speaking about something called as virtual environment. In Python, we will be able to create something called as virtual environment. It is like you have your software installed in your computer, right? So let's say this is Python. This is your computer and you have installed software, Python, and you're using it. So when you're using Python, there will be a lot of dependencies generally, right? These are with respect to packages, because some packages that we are looking at in geospatial analysis may not be able to give good results for other kind of data, or the general libraries may not work in geospatial analysis. So there could be interdependencies or right some kind of conflicts with versions and all those things. Depending on what project you are working on, depending on what kind of libraries you need, or libraries are nothing but pre-written code, right? So depending on what libraries you need, you might want to restrict your installation, your software that you're using to work only on that specific piece, right? Or only have those libraries which are required. So what we do is the Python environment, once you have installed, within that, we will create different virtual environments. Each of this virtual environment will be like an individual standalone installation, but it is virtually created, right? Virtual environment. And within this virtual environments, you will be able to install all the libraries that you want, which is specific to that particular module. So this is from a general best practices scenario. Project to project, you might want to have a separate virtual environment created. You might want to use that virtual environment for right, having the installations done. So this is with respect to the virtual environment. Then we will talk about now some of the packages which are specific, right, to your geospatial analysis. One of that is Gdal. Gdal is also known as Geospatial Data Abstraction Library, right? And you will be able to get the Gdal library in your package pypi.org as well. Let me show you. This is the centralized repository. In this, you might want to search for Gdal. Geospatial Data Abstraction Library. That's the first one, right? So I'll click on that. You have different versions also. Okay, and I'm going with the first one. Just to make sure that we take the latest one. I'm going with that. So this is the tutorial. You can also go through the tutorial, and these are ways to install your software. From Conda, you do that. From Windows, you do that. Right, and it basically says that there are certain libraries, certain conditions which are pre-required. It will be necessary to have an status installed if pip is expected to do some source building. So these are steps that you might want to stick to. Okay, so binaries you might want to first download, then follow these steps. So steps are clearly given Okay, what you are doing, how you are doing, the steps are clearly given there. So this is with respect to the Gdal, which is nothing but GeoSpatial Data Abstraction Library, right? And yeah, as you can see, it is clearly giving us the steps with respect to how the installation has to be done for right, these libraries with respect to different I mean different systems. Right? It can also be installed on Mac. It could be installed on Windows and all that. Next, generally in Python, right, for geospatial data especially, in general, we have a lot of data, geospatial data, right? It's a very large data that we generally deal with. And majority of this data is available over various platforms on internet. So if you have to work with data on network, in the network, then you need to have some of the functionalities that are required for us to deal with online data. Okay. So we will be able to do web extraction, right? Websites interaction. So we generally use FTP library, or directly you can use the URL to right, access to a specific location. The geospatial data is generally available in zip format. Okay, that's something that we try to understand yesterday also. Yeah, next. URL lib, that is another library extension of your FTP, you can say, I mean, remote network kind of thing. So we basically use URL library. This package is specifically designed to access the URLs, the URLs that we have. Okay, there are many such functions. One such function is open function. Open is basically a function which is used to access the URL content, and this is an inbuilt function. Okay, within Python we have inbuilt function. Then we also have retrieve function, right? Other things comes up. Then whenever we talk about accessing the data over internet, then we need to have one library called requests. Now this request library will allow you to access the data over internet. Right? So we need to install it and start using it to actually access the file. So you can say request.get URL. You simply say request.get, and then you pass the address URL. Right? This is one way to deal with this. So you will be able to get the data, probably you can say downloaded into your system. Right? And then we can also try and use open function, which will allow us to access the data that is downloaded here. Right? Then we also have something called as FTP, nothing but file transfer protocol. And these are global standards generally. Okay. And using FTP, we will be able to access the data from remote servers. Next. We will also talk about the markup language libraries. XML. Right? This is one of the markup language, extensible markup language. Right? Very, very popular with respect to dealing with website data or online data, to geospatial data also. And this XML is kind of a very unique library, methodology, which allows the system to understand the code very easily. At the same time, the developer also will be able to understand the code very easily. Well-known text. WKT, we are discussing about this, right? This is one of the formats that we can also use. Right, so that is with respect to markup language capabilities. And in order to parse this XML related data, we also have something called as mini DOM. That's a library. Mini DOM. But mini DOM is specifically good only for small or medium-sized documents, right? Maybe you can say 10 MB or 20 MB max. But if your data size is increasing, then you will have a challenge with respect to mini DOM. And definitely when we talk about geospatial data, the size of the data will be very huge. Then we have element tree. Okay. This is very similar to your mini DOM that we are looking at here. This is a pure Python library. Right. And when we talk about element tree. And this element tree basically is, you can say, more of an XML oriented library. Right? We also have C programming based library also. It's called as C elementary. This is a C based library. All right, next. The JSON libraries also are very important, right? Anyways, JSON is something which is very, very popular. And along with JSON, we also have something called as GeoJSON. Right? We discussed this format yesterday. We have GeoJSON. Yeah, these are your formats, standard formats. Next, in order to deal with this format, we need a library called GeoJSON itself. Again, you can search for that library here. I'll go back here. I will search for GeoJSON. Python bindings and utilities for GeoJSON, where GeoJSON is one of the formats. So these are all different functions that we can look at. And for installation, you will do pip install GeoJSON. You can see maps, tuples, geometries, polygon, right? Vector data, basically. Some of the examples are given there. All right, next. We talk about Py SHP shapefiles. We discussed about this, right? Shapefiles. Python shapefiles. The library that you will be using here is called as PySHP. Right? PySHP. Again, in order to check for this library, you'll search here in the search window. You say PySH. ESRI shapefile format. Python shapefile library reads and writes ESRI shapefiles in pure Python. Then we also have something called as DBF files. It's called as DBFPY. Again, it's one of the formats which depends on .dbf database files. And then more importantly, we will talk about Shapely, or I should say Shapely. Geometric objects, right? This is the library which allows us to deal with the objects like geographical locations and all that. The code examples, right? All these things are given. And this is what you will do for installation. Pip install Shapely. All right, next. We also have something called as Fiona. The Gdal library that we talked about, right? It's called as just now we have seen, right? The GeoSpatial data abstraction library, right? It's also called as OGR. Okay. OGR is specifically used for your vector data. Okay. So whenever we talk about this OGR library for data, then we also think about Fiona. It's a Python API which will allow us to access the Gdal data, publicly available data. The output of the Fiona library is going to give us in a JSON format, that is GeoJSON format. Right, and yeah, but that is Fiona. This is the library that we talk about, spatial data files, right? So Fiona reads and writes the geospatial data. So Fiona is designed to be simple and focuses on reading and writing standard Python IO styles and relies upon the familiar Python types class specific to OGR or Gdal. Right, so that's about some of the libraries that we basically look at. The NumPy, I mean, these libraries that we speak about, right? They are very, very common libraries. NumPy, Pandas, Matplotlib, Seaborn. So these are regularly used, but for geospatial data, we don't use these standard libraries. We will use different type of libraries altogether. Right, and we basically also look at visualization based libraries. We have something called as PNG Canvas, right? And this basically is a pure Python library which allows us to work with the capabilities of your canvas, right? Canvassing the data, more like representing images. Next, we talked about Pandas, right? And then we also now have GeoPandas, right? And this GeoPandas is built on top of your Fiona dataset, Shapely, right? Dataset, or you can also say visualizations like Matplotlib libraries. Okay, all these have to be working fine. It has to work with your GeoPandas library. Okay, next, the data can be stored in database also. We generally call it as Python MySQL. Now, PyMySQL is also a library. PyMySQL. Now, this is basically depending on the library that the database that you're using. The database that we are using here is a SQL database, right? So we'll basically try and enhance the SQL database specifically to place spatial data, right? Spatial data. This is an API-based concept, and then we have PyFPDF, PDFs. So if I say PyFPDFs, PyPDF, or I think it is PyFPDF. FPDF is coming, but our library is PyFT5. Let me cross check if this is available. Yeah, it is library, right? This is available. FPDF, simple PDF generation for Python. Next extension, we also have GeoSpatial PDF for enhanced visualizations. We have GeoSpatial PDF. Right. So again, installation and all that process is simple. You can just look into the archives and then install it if that is this visualization is right. I mean, the process of pip install and all those things are not working, then you can directly install it by accessing the draw location. These are used for visualization perspective. You will be able to deal with Python library. Then we have something called as raster.io. The raster.io library. It basically talks about wrapping the Gdal data, right? So on and so forth. Now I'll kind of wrap it here. There are a number of different libraries that you probably will see. I will try and explain a very simple execution of code that probably you might want to look into. So let me try and bring that up. Where is this? Yeah. All right. So this is basically my library. The portal that we are seeing, this is called as Google Colab. Google Colab, also known as Collaborator, Google Collaborator. Now I'm using Google Colab because in my local machine, we have a lot of dependency issues. I'll be generally using this local machine for different libraries and different actions. So basically, this is a challenge to use the code that we are using, because there will be certain libraries which needs to be mandatorily installed. Okay, so we are talking about trying to do something called as clustering and then generate a heat map. We call it as heat map. And this is being done on a data set, which is like this one, bearing bear underscore sightings. So this is to understand the bears. Okay, this is not the bear data. Let me try and open that. Yeah, this is your bear sightings. So we have latitude and longitude, right? And we also have that number. So we are looking at a public, available data, which is bear sightings, right? And these data points are captured, and this will allow us to come up with something called as heat map. The heat map basically is going to gray out the higher the number, more color it will be seen. And this scenario is basically talking about finding out bears. As I said, it is a small sample data. We are talking about a forest area, and within that forest area or within that area, where all did we see bears working. So we're basically talking about bear sighting. This is latitude and this is longitude. Right? That's basically how we read the data. Right? And if I talk about the example, the code. The first thing is we need to load the data here. Bear sightings. In order to update, once the system is ready, you will be able to, you'll be able to basically, right, be completing your use. There will be different files and folders. You might want to remove them if you're basically trying to use this Google Colab. Upload your file and keep it handy. Right, and then here we are importing Folia. Here we are using library called Folia. So it will allow us to create something called as leaflet over the images that we are trying to work with. This would enable us to generate a HTML library also. Right, so Fuelin is the library which allows us to make the leaflet web pages, and that will help us to create a HTML. So what I'm doing is I'm using the open function to read the file. You can remember this. Yeah, we're trying to read the data, whatever the data that we have. It's a small mocked up data. I have how many? 82 rows. That's all, right? Not big number. So we have used the open function to read the content. This is their mode. So what kind of operation do you want to do on that file? So I'm saying open the file and then only read it. So I'll say f.readlines. F is the library. I'll say f.readlines, and this would enable us to read the data. So I'm going to execute this. Just now I've executed. Then I will be executing this. Here we are loading the data and we are reading that data. Removing the first column, top 0 is basically removing the first column. And then we are creating a list called data. And once this data is defined, we are trying to capture the list of all the values where bears are spotted. So then we are trying to map the data using this logic. And then once the data is obtained, here we are doing heat map. Heat map basically talks about visualization with respect to the various coordinates. Right now, to deal with this particular data, we say m.save HTML. Heatmap.html. I'll save this. So what it is doing is it is trying to save a file here, which is not created yet. Let me just wait for that. Yeah, you can see the HTML, right? So you will be able to download this. I'm downloading the HTML file, and if I open that, so in Georgia, Mississippi, basically, right? These are the various locations where you're basically seeing the bears, right? So geospatial data is nothing but maps. So this is one such example which will allow us to highlight, right, whether you have found the sightings, right, bears or not in that particular area. So this is how your code will look like, right? And we'll also try and look at various other examples. All right, so this is basically the first program that you have showcased, visualized, see, and right, we will see some more use cases, some more examples, some more data sets in the other side, that is in the next class. So until we meet again tomorrow, have a good day or good evening and enjoy your evening, friends. Thank you.